welcome you all to the lecture series of Digital Electronics KE 039/049. We are discussing about synchronous sequential circuit. Already in the first part, in lecture number 20, we have discussed the synchronous sequential circuit basics, the types, and we have designed a clock sequential synchronous circuit. So, today in second part, we will be going into this detail. So, myself Dr. Kishanu Kundu, Assistant Professor, Department of Electronics and Communication Engineering, GLBITM, Greater Noida. We are going to start today's session. Let us proceed. So, today we will just revise the two different type of sequential circuit. Already I have discussed in the previous lecture. First one is Mealy circuit and second one is Moore circuit. So, from the diagram itself you can see the Mealy's machine, the output is the function of both input and the output. Mealy circuit having the output is function of both the present state and input. You can see from the diagram here the combination circuit C1, we are having memory flip flops where we are giving the clock pulse, the combination circuit C2 and the output is depending on both the things, that is a feedback. So, you can say the input combination circuit which is also called the next state decoder, what it receives inputs from the outputs of the memory element, it is getting the output from the memory element and from the external inputs. But the most important point to be noted is that the output combination circuit, that is this one C2 also called that output decoder, receives signals from the output of the memory element as well as the external input. So, this is the line, it is function of both present state as well as input. So, here it is written clearly the C2 receives the signal from the output of memory element as well as the external inputs. Hence, the output of Mealy circuit also dependent on the present state of the memory element as well as the external inputs. Clear? So, already we have seen Mealy circuit and we have drawn the state diagram, state table of the Mealy circuit. Let us revise once again the Moore circuit. The Moore machine, the output is a function of present state only. Previously it was present state as well as external inputs, here it is only the present state. Here also we are having two combination circuits C1 and C2, memory element, the flip flops, and we are having the combination circuit C1 on the input side is sometimes called the next state decoder, and the external inputs and the feedback signals from the memory elements are applied to the this combination circuit. Means in C2 we are having these two inputs, the external inputs and the feedback signals from the memory elements. Okay. The output of the memory elements are applied to another combination circuit C2 which is also called an output decoder. Okay. So, these are the two Mealy and Moore circuits. Now, we are continue with the designing part. Already in the previous lecture we will have discussed the steps of designing the clock sequential circuit. Again I am going to revise one more time. First of all, we have to take the state diagram. Already you know for different type of machine there are different state diagram, okay, for Mealy and Moore. So, from the state diagram itself you can will be clear that our circuit is Mealy circuit or Moore circuit. Okay. Now, from the state diagram we have to draw the state table. From the state diagram we have to draw the state table. Next, we will do the state deduction. If the values of states are similar, we will do the state deduction, then we will do the binary assignment to them. Next, we will find the number of flip flops. How many flip flops are required for designing that circuit? It is very important. Next, we will choose the type. If it is written, it is given in the question that you have to use this particular type of flip flop, then you have to use it. Otherwise, you have the freedom to use any type of flip flop SR, JK, T and D. But whichever flip flop you are going to use, you should remember the excitation table of that flip flop, because that excitation table is very important in our next step, which is we have to compare the excitation table and the state table, that is already discussed, right. So, excitation table is very important, and from the excitation table only you will be calculating the next the flip flop input values, right. So, then we will be having K map for the flip flop inputs as well as the output, and from the K map we will be getting the Boolean expression, and using the Boolean expression we will form the final logical diagram of clock sequential circuit. Okay. So, let us proceed. here one question is given. Okay. We have not told that it is milli or more, it is not given, right. From the diagram you have to understand that what type of circuit is given, and the actual question is you have to draw the clock synchronous sequential circuit for this diagram. Okay. So, here you can see the output is given inside the state, right. The output is given inside the state. So, from very beginning it is very clear that this is the Moore state diagram, Moore state diagram, because the output depends only on the present state, not on the inputs. So, from the diagram you have to first determine that which type of circuit we are going to design. So, it is from very clear, it is Moore state diagram. Here 3 states 0 0 0 1 and 1 0, S 0 0 1 1 0, and we have seen that if you are giving 0 as input, it is going coming to back 0 S 0, if it is giving 1 then it is going to S 1, like that. So, our next work is to form the state diagram. From this we have to make the state diagram. So, like that we can write it here. So, if A B, then A plus B plus and then Y, these 3, how many states are there? 0 0, will be having 0 0 0 1 and 1 0. Okay. From if you are 0 0 and it will be 2 things, 1 second, we will be having 2 states, one is for x equal to 0, one is for x equal to 1, x equal to 0 and x equal to 1. So, A plus B plus and A plus B plus. See. So, when 0 0 S 0 we are giving 0, it is coming back to 0 0 only, right, and output is 0, and if it is 1 it is going to 0 1. Clear from the state diagram? Again for 0 1, if we are giving 0 it is going to 1 0, and if it is 1 it is coming back to this, and in this case also output is 0, in this case output is also 0, and the last one 1 0, if we are giving 0 and 1 it is going to same 0 0, the and output is 1. See, output is written as 1. So, I have written this 1. So, this is the state diagram for the given state table, right. This is from state table, sorry, I have written the state table from using the state diagram. Okay. Clear? And in Moore machine you also know that the output is depend only the present state, the next state depends only the present state, and in Moore machine, Millet machine, it is depending on the next present next state is depending on the present state as well as input, but in this Moore machine the output is depending on the present state only. Okay. So, now we will write the same things, like see, I will rewrite the state table in this format. See, for every condition we will be having 2 values of input 0 1, 0 1, 0 1 and 0 1. Okay. But here you can check only 3 states are given 0 0, 0 1 and 1 0, 0 0, 1 0 and 0 1 and 1 0 means this one and this one. This is not there in the given state diagram. Okay. So, using that only we will write the final state table. So, here when we will be having and the values of A B, I will write that like here, when 0 0, when x is 0 we will be having 0 0, then we will be having 0 0, when x equal to 1 we will be having 0 1, we will be having 0 1. Okay. Like that, when for 0 1, 1 for x equal to 0, 1 0, 1 0 and 0 1, 1 0 and 0 1. Okay. Next, For 1 0 the values are 0 0 and 0 0, values are 0 0 and 0 0, 0 0 and 0 0. Okay. And outputs also we can write here, you can say the outputs are 0 0 and 1. So, the combination will be for first two case 0 0, then 0 0 again and then 1 1. Okay. Clear? We have written the state table using the state table. This is the main state table, from that we have taken this state table. Clear? But this 1 1 state is not given in the diagram, 1 1 is not there, 1 1 is not there. So, we will take that, here we will take dash, we in place of nothing is given. So, we will be getting as dash. Here we can use dash or 0, okay. It is not given here. So, you can write that here one important point you can write, in Moore state machine, in Moore state machine, if the output is not defined machine, if the output is not defined, we can use, we need to place dash or 0, do not use do not care condition, only dash or 0. Okay. यहाँ पे we do not need, यहाँ पे एक note लिख लो, note is do not use do not care condition, do not care condition. Okay. If it is not given, do not use do not care, just you put dash, that is enough. Okay. So, here I have written this is the next state. So, this is will be the, I can take any type of flip flop, right. Suppose here we are using D flip flop. So, this will be the input to the D flip flop DA and this will be the input to the DB, right. Two flip flops we are taking DA and DB. So, we will write the values for this. So, what will be the expression for A plus? It is 1 for this only, here it is only. So, here for A value 0, B value 1 or X value 0, for this we will be having A plus is equal to 1. So, you can write down A plus is equal to A bar B X bar. Is it clear how I am writing the equation for the A plus, right. Only here we are having 1, right. So, we are write like this, then B plus is 1 for this condition and this condition. So, here we have to follow this two table, and the values will be for B plus will be, we can write down as A bar B bar X, A bar B bar X plus here A bar B X, A bar B X, A bar B X. Is it clear to all of you? Okay. And for Y, Y is 1 for these two conditions. So, here Y will be for this two, this one and this one. So, Y will be A B bar X bar, A B bar X bar plus, and next one is A B bar X, A B bar X. So, see here without K map directly we can form the Boolean expression, because only single or 2 1 values are there. So, it is very easy. If it is more number of ones are there in the output table, you have to make K map. Here without K map only I can find out the Boolean expression. So, 3 equations we have taken, one is A plus, one is for B plus and one for Y, and A plus is the input to the flip flop D A, B plus is the input to the D B and like that. So, again I am going to rewrite the equation. Okay. So, here A plus is already I have taken A plus equal to A bar B and x bar. Here I have written it a bar, b and x bar. Then what is b plus? B plus is a bar, b bar x plus a bar b x. So, let us write it. So, b plus is equal to a bar b bar x plus a bar b x, a bar b x. So, here we can take common, a bar x will be common here, taking common it will be b bar plus b, and we know from the Boolean laws that b plus b bar will be, sorry, here b plus b bar will be 1. So, it will be a bar x, got it. And for y we are having what value? A b bar x bar plus a b bar x. So, let us write down y is equal to a b bar x bar plus a b bar x, a b bar x. Any common is there? Yes, we can take a b bar as common. So, we can write a b bar and it will be x bar plus x. So, it will be finally we can write a b bar. Okay. So, these three equation we have taken, this is for a bar, this is for b bar and this is for y. Clear? Now, it is easy, we have to make the simple diagram from this. So, two flip flops, flip flop D flip flop A, D flip flop A and D flip flop B, D flip flop A and D flip flop B. So, here will be D A, this is D B, this is Q A, Q A bar, this is Q B, Q B bar, and same synchronous means same clock pulse is given to both the flip flop, synchronous circuit, right. We are discussing about sequential clock sequential circuits. So, clock will be given. So, we have just made the format. Now, what is the formula for A plus? A plus is means DA, DA is nothing but this is the input to DA, this is nothing but DA, this is DB. Okay. So, DA is A bar B x bar and this is nothing but A bar B x bar, A bar B x bar, A is DA means A bar B x bar, and what is A? Q A is equal to A and Q B A bar is equal to A bar, Q B is equal to B and Q B bar is equal to B bar. Okay. So, Q A and Q B, Q A and Q B and X, the AND form will be given to DA, right. Clear up to this? Then what is DB? DB is given by A bar x, DB is equal to A bar x, means this is A bar and this is x, then AND gate, this is A bar x. Okay. So, this is DB is equal to A bar x, got it, and y is equal to AB bar, y is equal to AB bar, y is equal to AB bar, means this is A Q A and this is B bar. So, then this AND gate will be y, this is AB bar. Clear all of you? This is the final diagram of clock sequential circuit. We have just written Q A is equal to A, Q A bar is equal to A bar, B and B bar. Okay. Means this is Q A bar into Q B bar, right, Q A bar into Q B bar. So, finally, this diagram is completed. Okay. So, now let us take another example, okay, but there is difference. See, in this diagram the output is given inside, right, and output is depending on the present state only, not on the external inputs. But in this second diagram you can check that output is written with the inputs, okay. Output is written in the inputs. So, the output is not only depending on the present state, but also as the external inputs. So, this is the Mealy machine, it is nothing but the Mealy machine. I have already told that from the state diagram itself you can understand that we are going to make a circuit for Mealy circuit or for Moore circuit. Okay. So, here we are having 3 states 0 0 0 and 1 0. So, when we are giving, we can see like that 0 0 0 1 1 0 for x is equal to 0, x is equal to 1, and this is next state, this is next state, and this is for output for x equal to 0, x equal to 1. Okay. So, when 0 0, when 0 0 for x is equal to 0, it is going coming back to this same, and when x is equal to 1, it is going to S 1, and the output is 0 and 0, 0 and 0. Now, this is 0 1, this is actually nothing but 0 0, this is 0 1, and this is 1 0. So, when 0 1 is that, for x is equal to 1, it is coming back to here only same, and for x is equal to 0, it is going to S 2 1 0, and the outputs are 0 and 1. So, for 1 output is 0, and for 0 input this is 1. Clear? From the state diagram only we are making the state table, and the last option 1 0. So, 1 0 when we are giving input as 0, the output is 0 and going to 0 0 condition, 0 0 and output is 0, and x is equal to 1, y 1 is equal to 1, output is 1, again going to back to the 0 0. So, this is the final diagram, state diagram we have converted into the state table. I think it is clear for you. This is Mealy machine state diagram, we are doing the state table, right. So, now we are going to rewrite it as the previous one. See, for all the combinations 0 0, we are having 2 combinations 0 and 1, 0 and 1, 0 and 1 and 0 and 1. Okay. Now, we have taken this state is valid, this state is valid, and this state is not given in the question, right. So, we will just complete the table. Just take the values 0 0 0 1, 0 0 0 1. So, here to write that 0 0 and 0 1, then next value is 1 0 and 0 1, 1 0 and 0 1, 1 0 and 0, like that. The last one same we are doing that 0 1, then 0 0 and 0 0, 0 0 and 0 0, and outputs we are also checking. See, in the first case the output is for 0, it is 0, for x equal to 1 it is 0, then we can write that 0 0, then for x equal to 0 output is 1, for x equal to 1 output is 0, means 1 0, this is 1 0, and similarly the last one is 0 and 1. So, right now we can write that 0 and 1. So, up to this it is clear, whatever states are given we have drawn the state table for that, but this 1 1 state is not written here, 1 1 is not there. So, here we will put the do not care conditions, will be do not care. So, this is the only difference between Mealy and Moore circuit. Here I have told you, for Moore circuit if it is not there, the state is not given, put a dash or 0, but in Mealy circuit we are using cross do not care instead of dash or 0. This is the main important thing you have to remember. So, you can write like that in Mealy machine, if in Mealy machine if out state is not defined, state is not defined, place do not care, place do not care. This is very important point to be noted for Mealy and Moore. This is for Mealy machine, do not care, and Moore machine we have to put dash. Here we have written dash or 0. Clear? So, here now further steps are there, we have to make the K map, one K map for A plus, one K map for B plus and for Y. This is nothing but the input to dA, this is nothing but the input to dB and this is for Y. Okay. So, let us start the K map drawing. So, here this is for A plus means dA, this is for B plus means dB and this is for Y for the output. So, here the inputs are A, B and X, and write A, B and X, and here it will be written like this X and A B, just any type we have represented in vertical way, you can take any way for horizontal or vertical, that does not matter. So, the values are 0 and 1, 0 0 0 1 1 1 1 0. If you having any K map problem, any doubt, you just refer to the previous lectures of K map. Okay. There the grouping criteria, grouping policies are fully clearly described in that. So, from that table 0 0 1 0 0 0 cross cross. So, you just put that value here, it will be 0 0 1 0 cross cross and 0 0. Like that for B we will be having 0 1 0 1, see it is that 0 0 0 1 0 1 0 0 cross cross 0 1 0 1. So, will be written as cross cross and 0 0, see cross cross and 0 0, see 0 0. Okay. And for Y it will be written as, for Y will be 0 0 1 0 0 1 cross cross. So, it will be like this 0 1 cross 0 0 0 cross 1, 0 0 cross 1. So, now we will be make a grouping of this. So, one group will be this. So, the value of dA will be nothing but x bar b, x bar b, and here will be group like this, only this two group will be there. So, dB value will be x a bar, right. Just do the grouping of the K map, it is very easy, and for Y we will be having two groups, one is this group and one is this group. Then the value of Y will be writing as Bx bar plus Ax, Bx bar plus Ax. Clear? So, we have got all three equations. What are the equation? Again we are rewriting that dA will be x bar b, dB will be x a bar, and Y will be bx bar plus Ax, bx bar plus Ax. So, nothing left, already I have told in the previous question, just you will be having D flip flop A and D flip flop B, same clock pulse is given, synchronous clock. Okay. Now, for dA we are having, this is dA, this is dB, this is QA bar, this is QB and QB bar. We have written QA is equal to A, QA bar is equal to A bar, QB is equal to B and QB bar is equal to B bar. So, the final is x bar B, means D is equal to, this is B and this is x ka bar, this is x bar. The x bar B will be given to dA. then x a bar. So, this is a and you can write like this dB. Okay? Got it? You can take it from q bar also, q a bar also. Here also you can connect without any, yes, you can draw from this itself. No need from this, we will this write from this one, this q a bar here. This is q a bar x. Okay, dB is written, and what is y? This is nothing but a, this is nothing but b. So, b x bar, b and x bar, same like that you can collect this b x bar and a x, this is a and this is x. So, here we are having one AND gate and finally, this is y. So, y is nothing but b x bar plus a x. So, this is the complete design of a synchronous sequential circuit. We have discussed two type of circuits, one is melee and one is Moore. From the state diagram itself you can understand which is Moore, which is melee. Here from this diagram it is clear that this is a Moore circuit, because the output is given inside the state, okay, and output it depends only on the present state, not on the input. And here from this diagram you can check that the output is depending on the present state as well as the external input. So, it is nothing but the melee machine. So, from this type of diagrams, if they are asking you to design the clocked synchronous sequential circuit, then you have to follow the steps and it is very easy. So, the important points to remember: in Moore state machine, if the output is not defined, then we need to place dash or 0. We should not place do not care, it is very important point. And in melee machine, if the state is not defined, then we should place the do not care condition. So, these things you have to remember while designing the circuit. Thank you.